Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is April 16, 2024, and the time is around 3:09 a.m. Okay, my topic for this session will be, it's a random topic. This is a topic on integral calculus. So I've done already the subject matter integral calculus. So I will be adding this one on my random topic playlist. Okay, random topic that falls under integral calculus. Okay, let's proceed. This is a problem on integral calculus. So for those of you who are planning to take up engineering, this is for you guys, because I will be giving you one problem and I will be presenting three solutions. So after finishing this lecture, okay, at least you know how to bring out three solutions involving one problem. Okay, let's try to start. The problem is this one. Evaluate the integral of differential of x all over the square root of 1 plus x. The problem is asking us to evaluate the integral of this one. This is an indefinite integral. It got no upper limit and lower limit, so supposed to be our final answer should have a plus c. Indefinite integral, right? There is a plus c. Okay, let's try to bring out the first solution. On the first look, the problem seems it's an easy one actually. So the integral of dx all over the square root of 1 plus x by presenting solution number 1. And the title of solution number 1 is by using the so-called power formula. Power formula. Under the study of integral calculus, there is the so-called integral formula, the integral of u to the n du. And if we try to bring out the solution of this, it should be u raised to n plus 1 over n plus 1 plus c. Okay? That's the format of solution number 1. If you are sharp enough to visualize it. So for the given integral to fall under this, we must have to, what you call this, do some algebraic manipulation. So the integral of dx all over the square root of 1 plus x, this should be equal to the integral, okay, of 1 plus x raised to the minus 1/2 times dx. Okay? These two here are the same because if we try to remove the radical sign here, this square root is actually that quantity raised to 1/2. Right? So if we try to raise this value here to the numerator, the exponent now will be negative. Okay? So the original dx over the square root of 1 plus x, this can be written as the integral of 1 plus x raised to negative 1/2 times dx. And this is now similar to the form, the integral of u to the n du. Okay? The limit of this formula here is that this n here should be a constant. Should be a constant. Okay? So I place it here. If this one here is similar to this, my u here should be the value of the one inside the radical, the one inside. My u will be the one inside. This is u. So I place it here, u will be 1 plus x. the value of the 1 inside the quantity. That's my u. And if we try to take the differential of both sides, the differential of u will be du, the differential of 1 will be 0, and the differential of x will be dx. So du is equal to dx. Okay? I place it here, it is exact. So it seems this is our u to the n, and our du is this one. And this is exact. Okay? It's just dx. This is dx. So this is our u to the n, and this is our du. So if we try to integrate this one, this falls under the integral of u to the n du. And the proper formula will be u raised to n plus 1 over n plus 1 plus c. So rewriting again the integral of dx over the square root of 1 plus x equal to the integral of 1 plus x raised to the minus 1 half times dx. Okay? And this is now similar, like what I said, this form here, after verification, this is now falls under the integral of u to the n du, power formula. And if we try to integrate this one of the creators say that memorization is not thinking. Okay, if you cannot memorize anything under mathematics, you will not learn anything. I don't believe in that one. Memorization is actually a thinking thing, right? Because if you could not memorize, how would you learn? Okay, and the integral of u to the n du will be u raised to n plus 1 over n plus 1, this is plus c. So the value of u is 1 plus x. The value of n is negative 1 half, so this will become negative 1 half plus 1 over negative 1 half plus 1, this is plus c. Okay. Negative 1 half plus 1. Negative 1 half. 1 is actually 2 halves, right? So minus 1 half plus 2 halves will be 1 halves. So the exponent now, negative 1 half plus 1 will just be simply 1 half. This is 1 half. Okay, all over 1 half. This plus c. Okay. And if we try to simplify this one, okay, we will take the inverse. It should be 2 over 1 times this. So the final answer will be twice the square root of 1 plus x plus c. That will be our final answer. Memorization of formulas is one of the concepts on how we should learn. So, okay, don't discount memorization, because if you could not memorize, you will not learn anything, right? Solution number 2. Sometimes we don't agree with what other creators are saying, right? Solution number 2. Using algebraic substitution. This will be another form of solution under integral calculus. There are some problems which could be solved by the power formula like this one. And luckily, the given problem is also solvable by using algebraic substitution. So I will be presenting solution number 2, that is by using algebraic substitution. Algebraic meaning we will be presenting another variable, algebraic variable, right? So we will let z equal to 1 plus x. This is actually our algebraic substitution. If you could not memorize anything, you will not learn something, right? So we will let z equal to the square root of 1 plus x. We will try to remove the radical sign. We will square both sides. The square of z will be c squared. And the square of 1 plus x, square root. If we try to square this one, the square of z will be c squared, and the square of the square root of 1 plus z will just be 1 plus a. These two here cancel with the radical sign. Right? Taking the differential of both sides. This is under power formula. So this will be 2 times z times dz equal to, the differential of 1 will be 0, the differential of x will be dx. Solving for dx, we put it on the left. It will be 2z dz. So to bring out the solution, we must have to use this dx here as a function of the new algebraic variable and this here, this one. So the integral of dx over the square root of 1 plus x should be equal to the integral. Okay, dx is actually 2z dz as a function of the new variable, and the square root of 1 plus x from our algebraic substitution, okay, z is actually the square root of 1 plus x, right? It is this one. So it will just be simply z. Meaning the square root of 1 plus x is just z. So this will just be simply z. Okay? Okay, what's this one, guys? I am now trying to cancel z and z. The operation on the numerator are all multiplication. Okay? Luckily, the denominator is alone. So if the operation on the numerator are all multiplication, this would see here can be cancelled with this one, right? There is no plus sign or minus sign in between, right? As long as the operation is multiplication, we can cancel, right? So what will come out? 2 is a constant. We will bring it out. So this is twice the integral of the z. The integral of the differential of z will just be simply z. 2z. Okay? No lower and upper limit, so this is plus z. So to bring out the final answer, we must have to bring back the original variable, which is x. Okay? So this is twice. And what is z? Z from our algebraic substitution is actually the square root of 1 plus x. So this is twice z, which is the square root of 1 plus x plus c. This is our final answer. Same as this one. Okay? That's the second solution by using algebraic substitution. Okay, solution number 3. That is by using trigonometric substitution. So we will be using our knowledge of trigonometry. That's why integral calculus, one of the prerequisites is actually your knowledge of trigonometry. Okay? And the proper trigonometric substitution for solution number 3, we will let tangent of theta equal to the square root of 1 plus x. This is trigonometric, right? This is algebraic. Okay, that's the difference. That's why it's trigonometric, because this is tangent of theta. Okay. Let's try to remove the radical sign. So if we try to remove the radical sign, we will try to square both sides. Right? The square of tangent of theta will be tangent square of theta. And the square of the square root of 1 plus x, these two here, cancel with the radical sign. Okay, so it will just be simply 1 plus x. So we are now given a tangent function in terms of x. Okay, take the differential of both sides. Use your knowledge of differential calculus. Take the differential of the left hand side, take the differential of the right hand side. The left hand side, this falls under the power formula. Okay, because it seems this is actually tangent of theta quantity square. So if we try to take the differential, use your power formula. It should be n. The value of u is the 1 inside the quantity tangent of theta. And the differential of tangent, okay, this is now memorization, okay? One of my co-creators. If you could not memorize, you cannot solve the problem, okay? The differential of tangent is secant square of theta, differential theta. So we use the power formula, right? 2 tangent of theta. This is actually 2 to the minus 1 times the differential of tangent of theta, which is secant square of theta, differential theta, equal to the differential of 1 will be 0, and the differential of x will be the x. Solving for the x, we put it on the left. dx, we'll be rewriting this one twice, tangent of theta, secant square of theta, differential theta. Okay, it's not complicated as long as you know your identities or you know your trigonometric differentiation. So going back to the original problem, the integral of dx over the square root of 1 plus x should be equal to the integral. What is dx? Dx as a function of a trigonometric function is this one, right? So we replace dx by this. So it will be twice tangent of theta, secant square of theta, differential of theta. That's memorization, right? All over, what is the square root of 1 plus x? That's our original trigonometric substitution. It's the square root of 1 plus x is actually tangent of theta. So the denominator is tangent of theta. Okay? Again, guys, I will try to cancel out. If you try to notice it, all the terms on the numerator, the operation are on multiplication. These two here is to be multiplied by tangent of theta, to be multiplied by secant square of theta, differential theta. So all the operations are on multiplication. And luckily, the denominator is alone to be tangent of theta. So actually, we can cancel this one. Tangent of theta cancel with this one. Okay? 2 here is constant. We bring it out. So this is twice the integral of secant square of theta, differential theta. And if you try to recall one of the integration formulas under the study of integral calculus, again, this is memorization, right? Okay. If you could not recall your memorization, you cannot solve this one. So this will be twice secant square of integral of secant square of theta, differential theta. This is actually stuck, exact. And the answer here is actually tangent of theta. Because if you try to take the differential of tangent, it is secant square. So the integral of secant square of theta will be tangent of theta. So our answer here is actually twice tangent of theta plus c. Okay? How I was able to integrate this one? I just recall one of the formulas. Okay? That's memorization. That's knowledge. If you could not recall it, you cannot solve it. Okay? So this is twice tangent of theta plus c. But what is tangent of theta? That's our original trigonometric substitution. That is tangent of theta is actually the square root of 1 plus x. So our final answer will be twice the square root of 1 plus x plus c. So that will be our final answer. Same as the second solution, same as the third solution. So for tonight, okay, amen. We just solved the problem presenting 3 solutions. The first solution is by using the power formula. The second solution is by using algebraic substitution. And the third solution is actually by using trigonometric substitution. That's memorization. Okay? Memorization that I could recall it, right? Okay, so for those of you who would like to subscribe to my channel or would like to watch my channel, this is a long video format. This is for you guys. So if you would like to watch my channel is at youtube.com/@ProfDBJ. If you want to share it, please click share. Okay, good morning from Los Angeles.